There's a general structure to calculating confidence intervals. You take some parameter you're trying to estimate, we'll call it theta, okay, because this is what I'm writing here isn't specific just to this question, it's all confidence intervals, okay? There's something you're trying to estimate. Well, you add and subtract the margin of error from whatever that estimate is, and that's your confidence interval. The lower bound, the lower end of the confidence interval is done by minus. You find the upper end of the confidence interval, the upper bound, by doing plus. So this is a confidence interval. We want a confidence interval specifically for a population mean. So what we want to do is we want to take a sample mean, because that's our best estimate for the population mean, but then we want to add or subtract the margin of error from it. And so the margin of error, that depends on if it's a proportion or if it's a mean. That's usually the only two we do in this course, but there's lots of other confidence intervals. Margin of error depends on the number you're trying to calculate the confidence interval for. In this case, we're trying to calculate a confidence interval for a mean, and we don't know the population variance. It doesn't say anywhere in these instructions, this is the population variance. So we're trying to calculate t, and we usually call that t star. This is something we get from a table or from an online calculator. I'll do that for you in just a second. And then you multiply it by the sample standard deviation. Sample standard deviation divided by the square root of the sample size. So this is the formula we need for calculating a confidence interval of a population mean when we don't know the standard deviation. So a few of these numbers we know and a few we don't know. They don't give it to us directly in these instructions. They just give us the numbers. So we can use this, like Google Sheets to calculate the mean. And then they don't give us the sample standard deviation, but Google Sheets can help us get that. And then they don't give us t, but we can find out what t is according to the 99% confidence interval and according to the sample size of 10. So that's the tech piece that they try to make you use a TI for, but I don't think it's, you don't need a TI. It's actually way easier just to use stuff you can find on Google. Let's see. So we'll go to Google. Let's actually start with Google Sheets, because we need that mean and the standard deviation. Okay, the first thing I'm going to do is I'm going to type in all the numbers. And now I want to find the mean. I'm just going to label them just so I know. That's equals average, and it starts on A1, and then I'm putting a colon, and it goes to A10. So there's my mean of the data set. And the sample standard deviation equals stdev dot s, open a parentheses. You can actually just click and drag instead of typing it in the nerdy way I did it. So there's our sample standard deviation. So those are two things we need. Our sample mean is 1,245. I'm going to leave that space for t star. Sample standard deviation is 286.894, and I'll just round off there. And then a sample size of 10, so that's going to be the square root of 10 on the bottom. So we need this t star. So let's go back to Google. And let's do t-value calculator. Let's see what comes up. We want to look through a t. You can actually use Google Sheets for it, but I find like it's too confusing for students. They usually get it backwards, and that messes them up. What we're about to do is what people used to have to look up in textbooks in the back of the textbook. It's really just a boring way of avoiding the crazy calculus that happens in the background. It's not super crazy, but it is calculus. That's not a prerequisite for statistics. So you're not cheating by looking it up with an online calculator, because people were basically doing that back in the 1990s. They were using a calculator. Something was already calculated in the back of their book. Okay, the t-values, z-values from a table, don't feel bad about looking those up. Degrees of freedom. For this test, it's 9, because when you have just one mean, then it's the degrees of freedom is the sample size, which is 10 in our case, subtracted by 1. So that's why I use 9 for degrees of freedom. The significance level. So this calculator that I found, oh, it's going to be okay. Look, it's 99% confidence. That means we want to have 1% in our tail. So that's significance level there. So we hit calculate, and we want a two-tailed value because we're talking about a confidence interval. So our t-value is 3.24, should have left myself more room, 3.2498, and we can keep going. But that's the last piece we needed. Now we can start calculating the confidence interval. Okay, so 286.894. Oh, actually, I'm going to do the square root of 10 first in my calculator, so forget what I just typed. Okay, that's what the square root of 10 is. Now you could copy this back down, but what I'm going to do is I'm going to highlight a bunch of these decimals and press Control-C, or Command-C if you're on an Apple, to copy those decimals. And then take that top number and divide it by what the square root of 10 was. So we just found out this fraction is roughly equal to 90.72, and then we're going to multiply that to 3.2498. So our margin of error is 294.834. Does it say how many decimals? One decimal place. So I'm going to truncate this. Okay, 294.8. I should say, I'm rounding it. That's our margin of error. So now we're ready to finally put some answers in Newton. Okay, take that 1,245, subtract it by the margin of error. 950.2 is our lower bound. And then 1,245 plus 294.8, that's 1,539.8. There's our confidence interval.